Hello everyone. Welcome to the Dev Vibe channel. Last time we covered inheritance in Flutter, and today I'm going to show you how to use interfaces. This is an important topic, especially if you want to write clean and flexible code. What are interfaces? Let's start by understanding what interfaces are. In Dart, an interface is a kind of contract that a class must fulfill. This means that an interface defines which methods and properties a class must implement but doesn't specify how they should work. It's similar to inheriting from an abstract class, but with one key difference. Interfaces don't provide any specific behavior, only requirements. When you create a class and inherit it from another class using the extends keyword, the child class automatically inherits both the properties and methods of the parent class. For example, if you have a class animal with a method eat, any class that inherits from animal will automatically include this eat method. Now, let's talk about interfaces. Unlike inheritance, where the child class receives ready-made methods and properties from the parent class, interfaces don't pass anything along. They only define a contract, that is, a list of methods and properties that a class must implement. However, the methods themselves don't have implementations. To use an interface, you need to apply the implement's keyword. This keyword indicates that the class takes on the obligation to implement all the methods and properties described in the interface. Unlike inheritance, where the extends keyword is used and you can only inherit from one class, with implements you can implement multiple interfaces in a single class. Let's look at an example. Suppose we have an abstract class animal that contains a method eat, because all animals eat. Then we'll create two interfaces, flyable and swimmable. In these interfaces, we'll declare the methods fly and swim, respectively, but we won't implement them. The implementation of these methods will be left to the classes that will implement them. Interfaces and classes in Dart may look similar at first glance since both use the class keyword, but their purposes are different. In the abstract class animal, we define common behavior for all animals, whereas interfaces are created to add specific abilities, such as the ability to fly or swim, only to those animals that need them. For example, birds can fly and fish can swim, but these abilities are not inherent to all animals. Now, let's create a duck class. Since a duck is an animal, we'll inherit from the animal class using the extends keyword. But a duck can also fly and swim, so we must implement two interfaces, flyable and swimmable, using the implements keyword. Now we need to implement the fly, wata, and swim methods defined in the interfaces. In your IDE, you may notice red underlines. This indicates that the methods are declared but not implemented. To implement them, we use the ati override annotation before the fly and swim methods, showing that we are providing the implementation required by the interfaces. Now, let's create an instance of a duck. If we create a duck object and specify the type duck, we'll have access to all the methods: eat, fly, and swim. This is possible because duck inherits the eat method from animal and implements the fly, and swim methods through the interfaces. However, if we create a duck object and specify the type animal, we'll only have access to the eat method. This is because the animal type doesn't know about the fly and swim methods, as they are defined in the interfaces, not in the animal class. If we create a duck object and specify the type of an interface, such as flyable, we'll only have access to the fly method. This is because the flyable interface limits access to the methods it defines and doesn't provide access to the methods of animal or other interfaces. Now, let's talk about type casting. In Dart, there are two types of casting: implicit and explicit. Implicit casting occurs when we assign an instance of a child class to a variable of a parent type. For example, if we have a variable of type animal and we assign it an object of type duck, this is implicit casting. Dart automatically understands that duck is an animal, but if we want to cast back from animal to duck, we need to perform explicit casting. Imagine we have a variable of type animal, and we know it contains a duck object. However, Dart doesn't know this and will throw an error if we try to directly assign this value to a duck type variable. To solve this, we use the as keyword to explicitly specify the type. Now, the compiler knows that my animal is actually a duck, and the code works. It's important to remember that explicit casting can cause an error if the types don't match. Let's create another class fish, which will inherit from animal and implement the swimmable interface. And when creating a variable animal, we'll pass in a fish instance instead of a duck. If you try to cast an animal object, which is actually a fish, to duck, the program will throw an exception. This can lead to unexpected errors, especially if you're not sure about the object's type. To avoid such errors, you can first check if the object is a certain type using the is keyword. For example, before casting animal to duck, you can write a check if my animal is duck, and then perform the cast only if the check is successful. This will prevent exceptions and make your code safer. Today, we covered interfaces and their usage, as well as type casting in Flutter. Now, you know how to use interfaces to create flexible code and how to correctly work with type casting. At first, the difference between interfaces and inheritance may seem confusing, but with practice, it will become simpler and clearer. If you enjoyed this video, give it a like, subscribe to the channel, and hit the bell icon so you don't miss new lessons. If you have any questions or topics you'd like to see covered, leave them in the comments below. See you in the next video.